welcome to the two people in the room. This is Dan. Hey, no worries. It's I guess everyone was had a really exciting night last night.
Yeah, this is a rough time like that.
No worries. I've had worse. So this is Beyond Websites. It's using Drupal for digital signs. Link is there for later on if you want to look up slides. There's gonna be a lot of material here, so it's totally okay. Don't feel the need to take extensive notes. It can be a little overwhelming. So, and I'll bring it back up at the end. So don't worry. So I normally give this with a colleague of mine. He wasn't able to make it. But my name is Adam Weingarten. I'm a technical architect at Acquia. I help estimate, plan, build, and roll out sites. Hopefully with not too many disasters along the way. Every project is its own series of disasters, and my job is to figure out how to mitigate those and not let people see them.
Yeah, exactly.
So let's see. I'm going to skip over the slide about Mike. So why are we here today? We're here to talk about kind of next generation digital experiences that are unlike the sites that we're building currently. So we're not using a normal web browser. We're using different tools to convey information. So what could some of those look like? So we might be talking about like a personal assistant. So something like maybe a Siri, a Cortana, or like an Amazon Echo. There's some really, really cool ways that now you can interact with data. We might also be talking about like the touch screen on like a Tesla to interact with information. Or if you're in the mall, like a kiosk where you can get directions or get information. Or it could be something like public transit, where you're waiting for a train arrival and you're getting information. This is a sign that is on the New York MTA, with train arrivals, some weather, and then there's some notifications on the bottom. So that's a really good example also of conveying all that stuff. Talking about digital experiences, why are we actually here? We're here to talk about signs. So what are you going to hear about today? We're going to talk a little bit about content management. We're going to talk about working with external data transmission, a little bit about device management, security, support, and we're going to do a little case study as well. So that's the overview. So the first question is, why the hell would you even use Drupal to power a sign? Why not use something else? There are probably a bunch of other things that seem to make a lot more sense to use. The skeptics are saying that there has to be something better. I'm going to definitely cram in a bunch of buzzwords in this slide. So you could be doing HTML5, you could be using Symfony, Node, you could be using some combination of Angular, React or Ember to do a digital sign. Why would you use Drupal? There are so many options that are geared towards experiences and front-endy stuff. Drupal seems like the wrong thing to use. These are all great developer experience tools, but they have really, really bad user experience. And that's going to be a big theme in this talk. So, even in a headless world, there's a role for Drupal to play. At the end of the day, it makes it easy for people to author and edit content. It has views to let you display the content, and you then can use web services to spit it out to your headless system to do stuff with it. Why do we use Drupal to manage content again? Why aren't we doing something else? It has content modeling. So we can go and we can create content types that mimic things and ideas and concepts that we have. We have access control and permissions. We have revisioning, translations. And redoing all of this in a node or some other technology is freaking expensive. And if someone tells you that it's cheap, they're lying. There are millions of lines of code, I think, in Drupal core. I actually don't even know.
It's a lot.
It's a lot. It's more than I know. I can't count them. So that seems to be an expensive proposition to replace. At the end of the day, Drupal is letting normal people interact with the web. So this is why we use Drupal. We have this great page here where a normal person can select things from a taxonomy. They can put stuff into a WYSIWYG. You can upload files. You have revisioning. You can't do any of this stuff with just a normal node. There are some tools that are starting to come out, but they're very primitive now. One day, but not today. So what we're going to do is first look at a content model example. Oh, looks like I lost. Oh, give me a sec. Sorry, I am having technical difficulties. My slide notes are no longer advancing.
Oh, that's fine.
Yeah, that's always awesome. Let's see. Fortunately, these are easy things to fix. Oops. There we go. And we are back. So, content model. Let's say that we are trying to build a sign for a train system. So let's say that we are building the sign for the DC Metro. We look at this, and the first thing is we have train lines. So we've got red, blue, yellow, green. We have directions. So maybe I'm going to go in the direction of Shady Grove, or maybe I go in the direction of Glenmont. So I have choices. I can go in different ways. Then the other thing that I see here is I've got stations. I've got places where I'm going. And then I have maybe in the station, maybe over here, where I've got lots and lots of different train lines, I've got train platforms. So maybe on one platform I have the blue and the silver line, and maybe on another platform I have the red line. So again, it goes back to Drupal's content model. So we have those lines, all those different attributes. So MD8 makes it easy to build web services with this stuff. So you can create an API, you can spit it out. It also is really good with working with external feeds. So a lot of these times, signs are going to be pulling data in from someplace else, and then kind of rebroadcasting them. So on one of those earlier examples, like with the New York subway, they are showing weather information. So Drupal might not be the source of all things. It's a little bit of a shock. Everyone wants Drupal to be the center of the world. It's not. Wah, wah. But it can still help process the outside data. So what kind of external data are we talking about? So it could be social media. So maybe we have a sign that's showing your company's feeds. So everything from let's show your Facebook posts, your Twitter posts, and some Pinterest stuff, and we can mix it, normalize it, and maybe you have a slideshow that just shows that information. Maybe you have a feed at the bottom that just shows your latest tweets. You can do a lot of stuff with it. We might be talking about train arrivals. We might also be talking about weather, stock information. Top news is a big one. Those are all great pieces of information. At the end of the day, though, they're not really valuable without context. Context is what matters, and that's where Drupal comes in. We're talking about content models, and we can use that to process the data. So let's say that we have if we're looking at a train example, if we have an arrival feed, we can, that has arrivals for the entire system. We can look at that data. We can pick out updates for specific signs, and we can let the signs know when something has actually changed. So we're using the content model to inform our processing. So how does this actually work? We start with a drush command typically that is going to query those data sources, and it can keep hammering them, getting information. We typically will store the credentials in Drupal. We'll do some caching to enforce and respect the rate limits, and then we parse and do stuff to the data. Then once we have the data in Drupal, we then need to send it out. So we need to get information from Drupal to your device. We have two approaches that we can use to get data out. We have push and we have a pull model. Pull sucks a lot. So basically what the pull model is imagine that you are on a long road trip with your kids in the backseat of the car, and they're asking you every minute, are we there yet? Are we there yet? Are we there yet? Are we there yet? It gets really annoying really fast. It's annoying, so it's high traffic, it's high volume. It places load on the poor parent who has to listen to it. So you're not concentrating as much. You can't do as many other things. So your load goes up. Places load on the kids, because the kids now are like all amped up asking you questions, puts load on the parents, on the servers. And it also starts to look like a DDoS attack if you have enough signs. If you have lots and lots of kids that are overwhelming your servers, that's not good. So it doesn't really scale well. It's great for small volumes, like if you have a few signs here and there, or if, let's say, your rate is quite low. So maybe your kids are really well behaved, and they only ask you, are we there yet, once an hour. You can deal with that. That's okay. I don't have kids, but I imagine if and when I do, they will not be that well behaved. So I'm assuming that I will have this problem. So what's the goal? We want the ability to send data to lots of devices from different APIs in real time. What does it look like? So we have Facebook, Twitter, maybe weather, maybe train arrivals. They all go into Drupal. So Drupal has some sort of drush command that's processing all this data. It's doing some sort of processing. It doesn't matter what it is. It's doing something using that content model to decide how it goes out. And then it just simply pushes data to the kids. So let's say it's Mo and Shauna. Let's say Shauna only cares about when the red line arrivals are coming. Drupal can send her an update. Let's say Mo cares about the blue line. So we can send notifications when something relevant has happened on the blue line. So maybe we send a notification about the train arrivals, but maybe we can also send some aggregated data about stuff that's happening. So if there's, let's say, a flood on the blue line, we can send data to the sign that Mo is looking at. That's our goal. So the problem with that is data in real time is really hard. Caching is really messy. It gets in the way of everything. Ideally, you want to be able to, our Drupal sites and our Drupal, more importantly, our web servers, they suck a lot. Like they can't handle high loads. They can't handle lots of transactional volume. So we rely on layers and layers of caching. Well, if you're doing real time, layers and layers of caching just get in the way, and they're fundamentally opposed to the concept of real time. So if let's say you need to get a train arrival to your users within, let's say, 5 seconds, you can't really use caching. There's no way to do it. You want the data to be current over time, so you want to make sure that it's there and that the caching isn't getting in the way. You also have an issue where, in a lot of these experiences, especially with signage, users can't touch the sign in a lot of cases. Like, you have this sign on the wall, and if something goes wrong, they can't reload. Like, they can't touch it. Like, it needs to just work. So what's the solution? So what we've started to do is use WebSocket technology. This is like magic and awesomeness. It's amazing. Basically, what a WebSocket is, it's a long connection between your browser and some service. It allows two-directional instantaneous communication between the browser and whatever service you're working with, and it can be shared between different devices. So what this would let you do is, the minute that there's a change, you can then push the change over to your browser. And you can also use it as a broadcasting tool. So let's say that you have lots and lots and lots of signs all subscribed. You can send one message to a WebSocket service, and it will magnify the effect out to everyone. So you could have one Drupal server send one message to your WebSocket service. It could then broadcast that out to 100,000 people in real time, and your Drupal servers are ice cold. One request.
I have a question on that.
Yeah.
If you're doing that would you use like UDP for that and not trust that the end device is actually going to receive it? Or would TCP be, you do want to verify that?
So we'll get into that a little bit. There are, so a lot of these, I think actually I get into it in the next slide. But basically, and so what we end up doing, and it just crapped out again, sorry. Let me fix this. Use WebSocket. Okay. So what we do is we'll often use a WebSocket as a service. And sorry, I'm just going to pull up my notes again. Okay. So the one that we used in our recent project was actually Amazon. They have an Internet of Things API. It basically, like many Amazon services, it just scales. So you don't have to worry about a lot of the underlying details or an implementation about the WebSockets. It'll just provide you the resources that you need, and they bill you based on how much volume you're sending. So Amazon, I think, bills at like $5 per million messages. It'll go through a million messages pretty damn fast. So make sure you do your calculations. So you don't get like sticker shock about it. But basically, they abstract away a lot of those details that you're asking about. So they do a lot of the quality of service. They take care of the protocol. They're using MQTT, I believe, which is an extremely lightweight protocol. I think it sits on top of UDP, but I need to double check. Okay. But it's designed for working with IoT devices. The packets are extremely lightweight, very, very small. I think AWS actually only allows roughly like 500 bytes or so in the payload itself. So it's pretty cool. But the neat thing is, you look at this, and like I said, there's only one line from Drupal to that. So Drupal sends the one message, and then starts getting magnified to all the devices. So it's really powerful. So like I said, AWS. So you have a bunch of devices. They subscribe to, AWS calls them topics. Think of them as like channels. It's like, so you're thinking about broadcasting like television. So you have a broadcast channel. So maybe I have one channel for, I don't know, the blue line, another one for the red line. Drupal will subscribe. Drupal will push the appropriate data to the correct topics, and the IoT pushes those to the devices. Oops. So you have some data, and it'll go out. So let's say that I have some updates from source 1, and source 1 only affects topic 1 and 2, which is what devices 1, 2, and 3 are subscribed to. So they will get an update. But devices 4 and 5 are subscribed to topic 3, which has no updates. So they don't get any information. They don't get any traffic at all. So that's all really cool. But there are more problems. There are always new problems. So now we worry about device management. We have all these devices. So Drupal knows about data, content, but it only really works if Drupal has some knowledge about the devices. So what does Drupal need to know? So it needs to know about what every device actually cares about, and how do those devices consume data, and how do you make sure that only your devices are actually getting the data? So we start to worry about, if we go back to our content model, we think about, we have our metro. Drupal needs to know what directions do trains travel in, what tracks does a specific screen care about, what platform is it servicing, what station is that sign in, and what routes might run through that platform and station. So we need to know all of those things, so that way we know what the signs are actually consuming. So we create those content types, and then we use NT references to provide context that helps us then do that processing. Some of that metadata can also be used in reports, and we can use some of the structure for other data. So maybe we can send messages, or we can do slides, or place other things on those signs as well. So more caution. Fully bootstrapping Drupal can sometimes be slow, so just make sure you cache lots of stuff as much as you can, at least internally. You may not be able to use a CDN or Varnish, but there are things that you can. So what format should the data be? We need to worry about stuff like what screen size are we working with, what IP addresses are we hitting, what direction is the screen facing, what language should it display. So how do you make sure that only your devices are actually accessing the data? First off, add an IP whitelist to your system. Typically all these systems, either you're going to be paying for WebSockets, so maybe you don't want the public to start costing you money. So you could put all of your signs on a certain IP subnet and make it so that your system will only respond to those. Maybe make sure that your service requires some authentication. Also require two-factor authentication for user access. It's a good idea, and we'll talk more about that. So we're going to start to go into a little bit about security on these devices. So signs are exciting. You just created a real thing in the real world. Like, this isn't a web page on a computer. This is like, you walk up, there's a kiosk, there's a nice thing. Like, it's pretty awesome to actually build, to start to deal with hardware now. It's not something we get to do very often. So that's exciting. And everyone wants to hack it. Big bullseye. There are a lot of examples of people love to go after signs. It's like the ultimate hacker trophy. Yeah. So, just think about that. So the first thing you can do is give your hardware some love. Most of the time, these devices you're going to be using some sort of an embedded device. And they have particularly bad security track records. We've heard lots of stories about, routers shipping with default passwords, election machines also shipping with default passwords. I don't know what people's politics are, but I'm sure that will explain whatever they are, whatever side of the aisle you are on. And then also a lot of them, if you can get physical access, you can do all sorts of bad things. So, let's say you've created this sign where someone could just go and drop an HDMI stick into it and now put something nefarious that you really don't want people to see on your sign. So restrict it. Also remember that your hardware is not just hardware. That may be confusing. It's running software. You have these devices. Make sure that the vendors that you're choosing actually release patches regularly. Like if you're trying to select hardware and you see that there's never any firmware updates on a fairly regular basis for the device you're buying, maybe don't buy that device. You want to see a track record that they care about things.
And recommended frequency on that.
I don't know. I mean, I don't think there's a clear guideline, but I would look at multiple vendors and just like we have security vulnerabilities on Drupal, you're going to have security vulnerabilities in the Linux kernels that they're running. Yeah. So you just need to worry about those. Make sure that you have a plan for staying on top of those firmware updates, and just make sure that you have a contingency plan for when there's a published vulnerability, and get it done fast. And you need to think about that ahead of time. Because if you find out about a vulnerability and it takes you 3 weeks to patch it, you probably have already been hacked. So it's good to plan for those in advance. And even basically if it can connect to the internet, you can hack it. So even a TV, if you're like, oh, I'm just going to go to Best Buy and buy a TV and then mount it on the wall. Well, even that can be hacked. You don't think about that as a device that has firmware updates, but it does. So the next thing we're going to talk about from a security perspective is the source data. So we talked a little bit about some protections on the front door. You also need to guard the back door. So the back door is all the data that those feeds that Drupal might be consuming. So if someone wants to attack your sign, a great way to do it is to not attack the sign or to attack Drupal. It might be to attack the feeds that Drupal is consuming. So you need to make sure that those are just as secure, if not more secure, than Drupal. You need to do some sort of validation on Drupal to try to make sure that what you're consuming actually seems sane. Like if someone totally hacks your feed, have a little bit of a sense of what hacked looks like, and try to at least mitigate it or have some exception handling, and just audit your data periodically. So it's 2017. Use SSL. There's no excuse. No one wants a man-in-the-middle attack. So if you're not using SSL, it would be very easy for someone to intercept the packets and start injecting data into your feeds. SSL helps ensure that does not happen. It's a great way to vandalize your sign, and it's a go-live blocker. Do not let people bully you into going live if you don't have SSL certs in place. I have seen that happen where they have tried, and we have said no. Yeah. At the end of the day, yeah. It's not paranoia if they're really out to get you. They are. They're out to get you. Next thing we're going to talk about a little bit is fault tolerance. So you're putting a sign out there, and something goes wrong with a web page. Normally on a computer, you don't give it a second thought. You would, if it was you and you saw a problem, you would just hit the reload button and everything's awesome. Well, if you have a sign that's mounted to a wall, hitting reload is a pain in the butt. And if let's say you have a network of 1,000 signs or 10,000 signs, you're not going to hit reload on every screen. If you are, someone's going to be really angry, and you're not going to be happy either because you're going to be rebooting 1,000 screens. And when something goes wrong, people really, really notice. They are not happy. So, there are lots and lots of examples of failure. If you Google blue screen of death and signs, you will find tons and tons of stuff. Here's some ballpark. Yeah. Here's a stock ticker. I mean, there are so many cases of this, and it's so unfortunate. Kernel stuff is hard to handle. That's hard to be resilient for. But there are other types of problems that do happen that you need to worry about. So you want to be able to first gracefully degrade. So try to build things in a way that you're expecting failure. So expect that maybe your feeds go down. Expect that your WebSockets don't work. Expect that Drupal goes away. And that when that happens, somehow you're able to at least maintain some user experience. But even then, with all the exception handling and degradation that you're going to try to do, you're going to hit something that you cannot handle in your browser. You're going to hit a JavaScript edge case, you're going to hit some sort of a problem, some memory thing's going to happen, where you just, however good you are or however good you think you are, you're not going to be good enough. And that's okay. It's something to feel bad about. So at some point, if you're using, let's say, Chrome, you're going to see a browser error. It's going to happen. It's just not a question of if, it's when. So what do you do? What we've done in a couple of cases is we've actually used a custom Chrome extension to add a lot of resiliency. So there's an extension called Oh No You Didn't that actually allows you to reload the tabs in Chrome. So if you do get that oh snap page, it'll just try to reload the page. What we've done for our project is we've actually customized it somewhat so that when that happens, when we do get to that page, it will actually bring up kind of a failure page that's pretty. It has a clock, and it has the seconds incrementing up, and it has a little bit of branding. So it gives us that nice fallback even when everything has totally failed. And then what we've done is we've actually added some JavaScript to that little fallback page to try to reload after a minute. So it'll try to actually auto restore itself when we've totally lost total control over JavaScript and everything else on the page. Our page no longer exists, but the Chrome extension is independent of our page. So this was born out of, we had some O-snaps appear, client freaked out, and I mean, rightly so, they should never see those. And we learned, we had to come up with a better way to handle those. So that's what we came up with, and it's been great. It's definitely something that you should consider for a lot of projects. Finally, we're going to talk a little bit about support. So these systems that we're talking about are extremely complicated, and troubleshooting them is really hard. And when a problem actually happens, like, how do you fix it? Like, you've got feeds, you've got Drupal, you've got WebSockets, you've probably got some front-end code running. Like, what's the problem? Who knows? Like, if you haven't documented or planned things in advance, the poor person who's trying to support and troubleshoot it is going to die. Like, it's just, be kind to your support people. Like, they protect you, they let you sleep at night. Be nice. So let's pretend that you did not see this presentation. You have some devices that are maybe using Angular to pull lots of APIs in real time. They're doing it directly. So you have Angular on the browser. It's hitting some web service. You didn't load test anything before you did this. You added 20 new screens in production. Okay, maybe this is only 10, but pretend it's 20. So all of these screens, they're hitting the APIs, they're hitting Drupal. All of a sudden, everything goes down. All the signs die. How are you going to fix that? What are you going to do? What happened? Did, the APIs go down? Did the web server crash? I don't know. I've got no idea. And I'm sure you don't either. So make sure that you understand the architecture. Make sure that support knows what those APIs are. Make sure that they understand what they are, how to test them, how to isolate those as false. And make sure that you've documented what are some of the warning signs when something really does go wrong. So that way they can kind of start to feel out things and know what to do. And ultimately you need to have an escalation plan in place before this happens. Like, that's the most important thing. So who owns the APIs? Who are you going to call when it goes down? You're not going to call Ghostbusters, but you're going to call someone. So just figure that out. You don't want to do that on the fly, and know what you can and can't fix, and know that before the bad thing happens, because there are some things that maybe you can't fix. Like, maybe if there's some third-party API that you have zero control over, maybe that's something that you can't do anything about. Like, if you've started to throw extra load at some other API that isn't designed to handle that load, there's not much that you can fix there. All you can do is maybe put some band-aids on it. So understand those. And part of that is test a lot, before. And ultimately that's all about load testing. Load test before you try to scale up. Make sure you have an understanding of what you can scale for. So especially if you're doing polling, make sure you have some ideas. Like, if you're doing a polling model, you should be able to kind of figure out, okay, I project that I can handle maybe 20 to 30 screens. Maybe I can't handle 40. Maybe 40 is where that's the straw that breaks the camel's back. Do you have a question?
No.
Okay, cool. So just make sure you have some ideas and mirror the production hardware if you can. It's expensive sometimes, but make sure you actually have tested the real thing, because as much as we want to think that we can calculate and estimate and expand on those numbers, we all suck at estimation.
Is there a way to mirror the production load?
Yeah.
Traffic as well?
Yeah, absolutely. There are lots of different tools for load testing. You could fire up JMeter. JMeter is generally the best way to start to simulate load tests. I think that's generally what our teams do. I need to double check what exactly they did to load test this. I am not the load testing expert.
Yeah, fair enough.
So, but yeah, JMeter generally, there's like Blaze Meter. You can generate tons and tons and tons of traffic to hammer your site. So it gives you pretty good indications. And also make sure that you are load testing the APIs too. So make sure that they're at production scale as well. It's important. And just remember, those APIs aren't going to be as robust as your main site. And also make sure they're not changing things without telling you. If you can, try to communicate. Communication is key. You don't want to be testing their changes randomly in production. That would suck a lot. So I'm going to go through just a quick case study. So this is for a large transit association in the Northeast. I can't tell you who. It's not Boston, so it probably makes it pretty obvious. They had, roughly under 5K of devices. They needed real-time data. Real-time being defined as, less than 4 to 5 seconds from when the data is triggered to being on the sign. So we basically had digital screens. We had content, so we had arrival data, and then we had messaging, so like a ticker at the bottom with emergency communication and some just general status updates. So what are some of the challenges? So real time across thousands of devices is hard. Internet WebSocket connectivity is kind of new, so we use that to solve some of it. Error handling and recovery, we spent a lot of time learning about that. On-demand messaging, so being able to get new messages out to those signs immediately when someone needed it or when there was an emergency was a critical requirement for us. And the performance was important. We needed to make sure that all this stuff ran reliably.
So all the devices, were they all their own topic, or were there like bundles, 3, 4 signs per channel topic?
We bundled them. So yeah, so basically, I think what we did, I forget what the exact partitions were, but I believe that what we did was we partitioned them maybe like by train line. So we would give the updates for the line, and those would be what we were broadcasting. So when there were updates to a specific line, so maybe we'd have like topics.
Okay.
I need to double check the exact specifics of what we ended up with for those. But yeah, if you can have some small limited number of things that you broadcast, then that means that Drupal only has to send maybe 12 requests every 5 to 10 seconds. If Drupal has to start sending, if you have, let's say, 100 topics, then Drupal has to maybe send 100 every 10 seconds, that starts putting more pressure on your web server. So if you can have your topics be a little bit broader, it takes the pressure off of Drupal in terms of the transmit, and lets you leverage Drupal more as a broadcasting tool. That's a really good question. So the approach that we used is that the arrivals were a feed. So we took that data into Drupal, we parsed it. We had some Drupal content for some of that messaging information. So let's say we had some slides that we wanted to show on there. Content editors could go in and they could create a new slide or upload an image, and then they could pick which screen it went on. So we talked about that user experience. Well, this is that user experience. Like, we're using Drupal to allow mortals to change a sign. Like, that's really powerful. And that's really different than a lot of digital signs aren't a new thing. Anyone who's been in a train station, an airport, or seen a stock ticker, signs have been around for a long time. But they've been a pain in the butt to change. So Drupal really is a tool that allows you to manipulate that data easily, in the way that we're all comfortable with. And more importantly, that like, not us, because we're all weird and we all do Drupal development and or are pros, but people who are normal, who may not be the greatest technical people or project managers who are familiar with Drupal. Normal people can go and make changes. We did the Amazon IoT WebSocket push funnel that we talked about. and we used a React front end to consume it. So this actually was a fairly headless decoupled site. It's unusual. All the display logic was really partitioned over onto the React layer. So Drupal wasn't doing a lot. So it was really just consuming data from Drupal. So it really was a great example of decoupled, but the right way. Decoupled is not always the right solution. That's a whole other talk, though. And then we kept an inventory of some of these different parsed assets and things, and cached them heavily, just try to speed things up as much as possible.
I have a quick question.
Yeah.
You mentioned before the packets that you were sending, they were capped at...
Yeah, like 500 bytes.
So if you're sending a sign with like a picture, how is it segmented? I mean, or is it somewhere else? Or
Well,
loaded onto the devices?
so all we need to do is send a link.
Okay.
So that's small. The images themselves can live over at Drupal.
Oh, okay, I got it.
Yeah,
Right.
yeah. All we need to do
Sorry.
is just signal that there's a change.
You're sending the source, not the actual assets.
Correct. Yes.
Okay.
And then the other thing is we did some minification before we transmitted to compress the data as much as possible. So maybe instead of using the full station name, maybe we would minify those.
Or use an ID. Or
Yeah, use an ID. So that way we're further compressing the data as much as possible because we have that packet is a scarce resource.
Yep. Okay.
So, but yeah, there are lots of things that you can do to cram that data in. So we were able to kind of target and message to the right audiences using those WebSocket channels. Rival data changes on screen within 5 to 8 seconds. I think in most cases it's actually closer to 4 to 6 seconds. So the minute that they receive an update that a train has passed a certain waypoint, it gets the API and then we process it and get it out to the sign. The WebSocket transmission itself typically takes like 200 to 300 milliseconds. Like it's wicked fast. Because we're using AWS IoT as the WebSocket as a service, it's massively scalable. They just auto scale for you. And then, like I said, it's got that great user experience for our content managers. So they can go in, they can make changes. So, wrap up. So we talked about why Drupal is a good idea for signs. We talked a little bit about a few techniques and did a quick case study about kind of how we used them. So that's our talk about signs. Do you guys have any questions?
So I guess you talked about like what happens if the display can't connect, I guess, to the system. But what happens if like a display just goes down? Do you have a way of on the server identifying this connection, like this WebSocket broke, and we can notify someone that, hey, these signs are down to go fix them?
We have been thinking about that a lot. So one of the things that I think we're starting to implement is like a heartbeat on them. So the signs will connect and they'll generate a GUID on the client side and then start sending a heartbeat. And then when the heartbeat stops, then we send a notification that a specific sign stopped transmitting. And then we have like a profile of what that sign was. So it's a way that you can track that information.
Yeah.
There are also some people that want to even go farther and store what was exactly on the sign at a given time. That becomes extremely problematic because you start to get into big data territory, stuff that Drupal is not even close to being suited for. So if you do have to start auditing to that level, you have to be very, very careful that you do not ever store data like that in the Drupal database. You will fill your database in 2 seconds, and MySQL is not the right solution for that.
You were saying the updates were under 10 seconds. Cron runs once a minute, so how does that?
Yeah, I actually pulled, I had some slides to talk about that, and I pulled them out because I wasn't sure we'd have time to get to them. Basically, what we've done is, this is one of the main issues, is cron, for those who don't know, is a tool for running repetitive jobs. The smallest granularity that cron allows for is 1 minute. That's the greatest thing. So what we did was we actually created, we did basically kind of a loop in the minute. So we basically had a start time. Once it got invoked, we would just keep running and looping inside the cron job for roughly like 55 seconds. And then we would stop, and then the next cron job would come along and let it go. There were a couple of other approaches that people have done to fake it. I've also seen people spawn additional processes to do that. I've also seen some people kick off just a loop via cron that just runs infinitely and has a file lock. There are lots of ways to kind of fake it until you make it.
Okay. Thanks.
Yeah. Other questions? No? Great. Well, thank you very much. I appreciate you listening and coming.
Well, thanks, man.
Yeah.